distribution? And is there a way in which we can generalize this? And for given some other structure, can we define a property which has to be satisfied by a sequence or series so that it can be generalized? Is there a possibility?
Sure. Yes, 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 of course there is. We found a relationship between distributions of order k and one other sequence. I don't recall how we call this sequence. It's one of the most famous sequences, along with Fibonacci numbers. So I'm sure maybe you can find something else as well.
Thank you, Professor.
Thank you too. Thank you too.
Thank you, Professor Filippo. Thank you, Dr. Viswanathan, for that interaction. Any other questions from the audience? There is no question, and I think Professor Satish.
Yeah. Thank you, Professor Filippo. In fact, you are very excellent, informative talk, and it is very useful to the youngsters in particular.
Thank you too. We will be in touch. Thank you.
Thank you so much. Also, we would like to thank the chair, Martin, Professor Martin.
Thank you, Professor Satish.
Nice session. And we are grateful to both the professors, especially Professor Filippo is a great personality, and we are very lucky to have your presence here in this platform.
Thank you. Thank you.
Adinanda, please conclude this session, please.
On behalf of the organizing committee of Wsta 2026, I extend my sincere gratitude to our session chair, Professor Martin Luther William, for his valuable guidance and for chairing this technical session so effectively. I express my heartfelt thanks to all our distinguished speakers, Professor Andreas and Filippo, for his excellent presentation and for sharing his valuable research and insight with us. I also extend my sincere appreciation to all the participants for your enthusiastic presence, active participation, and engaging interactions, which greatly contribute to the success of the session. Once again, thank you all for being a part of this wonderful section. Thank you.
Thank you. Thank you very much.
Okay, now let us move to the next session. Once again, thanking you, professors, for your support and blessings.
Thank you, sir. Thank you.
Yeah, thank you. Fatima, please. I hope just a minute. Oh, we have some time. We have few minutes to start the next session. Next session start at 3 p.m. Since we maintain the time and now we are little bit early. So few minutes, 5 minutes we can. Professor Kachashvili?
I am here.
Yeah, okay, Professor. Okay. Within 2-3 minutes, I think Professor Ashish Gupta has to join, isn't it? Professor Ashish Gupta?
Yes, sir.
Yeah.
In the meantime, if can I take some more time?
Yeah, please.
Professor, please. Having one more question there.
Yeah, you can please. Yeah.
Sir, Professor, you are talking about the extension of the thing to continuous type distributions. And my suggestion or probably my doubt is that if it is over a finite interval, okay, and extending it to infinite, okay, let it come sometime later. If it is in a finite interval, okay, if you are able to extend it, this finite structure to a dense set or dense subset of the continuous finite interval, is it not possible to extend for the entire set by way of the dense property of the real line? That's my doubt.
I hope Professor has some network.
Okay,
issues.
okay, okay.
Filippo is not there, I think. Yeah.
Probably, yeah.
Professor, while we extend to the continuous situation, there requires, we mentioned, there requires some other form of formulations. In fact, here in the discrete situation, the order K distributions developed initially by the generalizing geometric, Poisson, etc. Poisson as you, for example, we take the Poisson distribution. They have whether they consider as the stuttering Poisson as the or Poisson singlet, Poisson doublet, Poisson triplet, like that. Such distributions are taken and they obtained the sum of those. And
Yeah, that is
yeah,
true,
yeah,
Professor. But my idea is something like probably Professor Martin will be recognizing this because he is
okay.
also known to Professor KB,
Ah,
who put forward something of this sort.
okay,
That is,
okay.
if you are able, see, distribution has to be thought of something like distributing probability over a set. That set can be countable, countably infinite, finite, or uncountable. All
Okay,
that
okay.
the idea of distribution is to distribute the value in such a way that the integral over the set should be 1. If it is discrete, sum should be 1.
Yeah,
If it is continuous, integral should be 1. So
yeah,
all that matters is we need to attach certain values at every point.
yeah,
So
yeah,
what professor was telling is that for discrete, this can be done.
yeah, yeah,
So I thought of extending to continuous when you
yeah,
are able to simply taken for in the interval 0 to 1, if you are able to take all 1 by n's, and if you are able to distribute to the probabilities, okay, we can
yeah, yeah,
extend to all irrational numbers because we know the property that every irrational number can be approached by a sequence of rational numbers. So that limiting thing can be taken, and the overall integral can be adjusted by suitably dividing by the adjustment factor. So that's the way I am thinking about.
okay, that's okay. Anyway, we can think of
Dr.
such.
Viswanathan, you are giving a new thought to the
Yeah,
No,
entire thing. So it's good.
it's all because of your teachings from you great professors in Loyola.
Yeah, I was also taught by
yeah,
Professor K. Balasubramanian, Professor Durarajan, and Professor B. Chandrasekhar. Yeah, Dr.
yeah,
Viswanathan also, both of us are students of Loyola. Yeah, so
yeah,
Dr. Viswanathan's question is, yeah, it's a new thing that we have to think of. Probably we'll have to think of that. One thing what I did with one of my students, PhD students, was to generate a non-mesocratic family of distributions, univariate as well as multivariate. But then it has not come to the light. It has not come to see the light of the day. Much of the work is still remains unpublished. So probably we'll have to do that. But what you are asking is a different thing from a different perspective. So maybe we have to go and search. We have to search a lot. I'm not very clear about it right now.
Thank
so
you, Professor, for your comments and updates.
Thank you, Dr. Viswanathan. So once again, I should appreciate Professor Satish for his untiring interest. I don't know if any other university is doing this every year consistently without fail for the National Statistics Day and also in the month of December. So thank you very much, sir, Professor Satish Kumar. I
thank you.
really appreciate your involvement, your interest, your inquisitiveness, and whatnot, and all your colleagues. Thank you so much.
Thank you, Professor. Thank you. In fact, all these are because of people like you, Professor. like in fact.
It's a pleasure, sir. It's a pleasure. Thank you.
Now we have 2 more minutes. By the time, let us wait for Professor Ashish and Gupta to chair the session. Yeah, Professor joined. Okay. Professor Ashish and Gupta joined. I think, I hope. Professor? Fatima?
Yes, sir.
Can you hear me now?
Yeah, we can hear you, Professor. We can hear
Okay,
you.
now let me put on the video.
Yeah, let us start. Professor. Okay.
Good afternoon, everyone. Welcome to the 15th technical session of WSTA 2026, 11th International Webinar on recent trends in statistical theory and its applications. This landmark session is a prestigious keynote session in honor of Professor S.N. Roy, celebrating his foundational and revolutionary contributions to multivariate analysis and statistical inference. It is my distinct privilege to introduce our session chair, Professor Ashish Sengupta. Professor Sengupta is a highly distinguished statistician serving as a CSIR scientist for the Government of India. On the global academic stage, he is adjunct professor at Wsta University, USA, and a distinguished professor at Middle East Technical University, Turkey. With an outstanding legacy of international research, public and academic leadership, we are truly honored to have him in this session today. It is now my pleasure to introduce our distinguished team of speakers for this special session, joining us from Tbilisi State University, Georgia. Professor Carlos J. Kashiashvili, a world-renowned authority on mathematical statistics, mathematical modeling, and advanced data analysis, and a distinguished academician of Georgian National Academy of Sciences. Losab K. Kachiashvili, an active researcher and specialist in applied statistics, computational methods, and software systems. Professor Ashish Sengupta, who brings his extensive global research expertise in multivariate analysis and mathematical statistics. We eagerly look forward for their insightful presentation. I now respectfully invite our session chair, Professor Ashish Sengupta, to kindly take over the session and commence the proceedings. Over to you, sir.
Welcome, Professor.
Yeah, thank you very much for the kind introduction and also to the session. So it's my privilege and honor to chair this session, which is to honor Professor S.N. Roy. And of course, no one needs introduction to Professor S.N. Roy's work. So he has made seminal contribution, and it's only befitting that Professor Carlos Kachavelis is giving a talk in this session, because he has been working in this multivariate analysis area also in the inferential aspects. So I think Satish has done an excellent job in choosing him to give this particular talk. Now, just a slight introduction to Professor Carlos. Of course, my previous introducer, she has already said a few things. But Carlos's main work, among many others, I think the main work is basically on trying to revolutionize the area of inference by bringing in what is called constrained hypothesis testing. So in which he attempts to actually optimize both the type 1 and type 2 error. We know that we can't simultaneously minimize those. So his main contribution has been in that area, and that is because that is a mathematical problem, optimization problem, along with the inferential problem. So he has made substantial contribution to that, and I am pleased to have been a co-author of several of his papers. And today he is going to present, I believe, a joint work of ours on that area. So our students will, I hope, will enjoy that, because there's a lot of ideas that will come in, new ideas, and you'll be able to hopefully use those. Okay, with that introduction, thanks, and thank you very much, Satish. Let's go over to Carlos. Carlos, over to you.
Okay, thank you. It is seen my presentation?
Yeah, I can see the presentation.
Okay, thank you. Thank you very much. First of all, I would like to express my sincere gratitude to Dr. Shashi Kumar for his great work and for giving us the opportunity to present at such an important conference. Our presentation title is Solving ANOVA Problem with Restricted Type 1 and Type 2 Error Rates. The problem of comparing the means of several normally distributed random variables attracted researchers' attention from the middle of last century. Such problems arise in many practical applications, for example, at comparing treatment effects in clinical trials or experimental studies, at comparing effects of different experiments, or at comparing the failure rates of a machine with its age. Presentation structure is given on this slide. After introduction, methods of testing multi-directional hypothesis for solving the stated problem is offered, and in next items, algorithms for computation are presented, and in item 4, computing results will be shown, and in final 5 and 6 items, a short discussion and conclusion will be offered. Finally, I will show references which we use at working on this paper. In the framework of ANOVA, the problem can be formulated as follows. Let's consider K normal populations. Let xi1, etc., xi be a random sample from normal distribution independent from each other. The problem is to test basic hypotheses which suppose that mathematical expectations of these populations are equal to each other, and it must be tested versus alternative 1, which supposes that for some couple of mathematical expectations, they differ from each other. In some studies, the researcher may believe before observing the data that the true means are simply ordered. For example, the treatment means may be a sequence of increasing dose levels of a drug. In this case, ANOVA takes the following form. This statement has received considerable attention in the statistical literature. Some of them are shown here. The simplest case when k is equal to 2, this is the case when only two normal populations, call it as the Duhem-Fisher's problem, is well studied. For its solution, at the statement 1, a simple and accurate method was introduced in the works of Welch, which were published in 1947 and 1951, which gives good results in both cases when variances are equal or are not. After that, this problem for arbitrary case when k is greater than 2 was discussed by many authors, but unfortunately, it has not been possible to solve it to the proper levels by limiting the type 1 and type 2 error rates. For statement 2, A one-sided studentized range test is offered in the work of Hayata, which was published in 1990. It provides simultaneous one-sided lower confidence bounds for ordered pairwise comparisons. Similar inferences procedures are discussed in many other works. Some of them are introduced here. In some of them, the strong order of arranging the mathematical expectations is considered, and in others, the assumption that MIs follow a simple ordering is not made. The family-wise error rates is used as an optimality criteria in these cases, the computation of which is complicated for large K. For overcoming this problem, empirical Bayesian approach of multi-testing is offered in this work. Its essence consists in the consideration of the families of hypotheses, these hypotheses, from Bayesian viewpoint. For justice, it should be said that all the considered tests have quite high type 1 and type 2 error rates, the values of which depend on the parameters of the problem under consideration, the values of K, variances, and some sizes, and their control is impossible at a predetermined level. Therefore, to solve this stated problem, we have aimed to develop a method that would allow us to make a decision by restricting type 1 and type 2 error rates to a predetermined level. To achieve this goal, the constrained Bayesian method, shortly CBM, is used below. Without loss of generality, we can suppose that all mathematical expectations are positive, because if this condition is not fulfilled, we can always achieve it by moving the origin. Let us rewrite introduce above hypothesis in the following form, where parameters theta I are difference between neighboring mathematical expectations. In this case, hypothesis about arranging mathematical expectations, which number was 2 and was shown above, takes the following form. Using the concept of directional hypothesis, hypothesis 4 can be considered as a set of directional hypotheses, where basic hypothesis is tested versus two alternative ones, left-sided alternative and right-sided alternatives, and such subset of hypotheses is equal to k minus 1. This statement allows us to test initial hypotheses simultaneously using technique developed in our previous works. In particular, after testing hypothesis 6, if for even one value of I, left-sided alternative hypothesis is accepted among accepted alternatives, except alternative hypothesis that some mathematical expectations differ from each other. If all the accepted alternative hypotheses are right-sided, except alternative hypothesis that some mathematical expectations differ from each other, and they are ordered, otherwise accept no hypothesis. Let us recall that for testing above introduced hypothesis, ordered hypothesis, we have the following information: xi1 xin, which is a random sample normal distribution, on the basis of which the estimations, mathematical expectations, and unbiased estimations of variances are computed. For testing hypotheses concerning parameters theta, sufficient statistics is yi bar, which is difference between neighboring mathematical expectations of neighboring samples, And this statistics is distributed by normal distribution because these statistics are independent. Parameter theta equal to 0 at basic hypothesis, and it is this parameter is negative or positive at alternative hypothesis accordingly. For ease of presentation and understanding, let us firstly consider one subset of individual hypotheses, and for simplicity omit the index I. Let us use one of the possible formulation of CBM, in particular restrictions on posterior probabilities of rejected true hypothesis, which we call task 7 in accordance of our previous works. In this formulation, type 2 error rate is minimized. That means the power is maximized and type 1 error rate is restricted. Statement of the problem has the following form. We maximize the average probability of correct decision subject to the average probabilities of incorrect decisions and validity of different hypotheses. For solution of this problem, we use stepwise loss functions, where Ki is loss of incorrectly accepted Hj hypothesis when Hi is true, and K0 is loss of incorrectly rejected Hj at testing it versus Hi. Using undetermined Lagrange multipliers, solution of this problem has the following forms. They are K minus and so on. They are hypothesis acceptance regions, and Lagrange multipliers are determined so that in the appropriate restriction conditions equality takes place. The most common criteria of estimation of the quality of testing directional hypotheses are the mixed directional fast discovery rate and false acceptance rate, which have the following forms. According to the theorems proven in our previous work, if the condition is satisfied where Q is some probability, P minimum is minimum among a priori probabilities of hypotheses, then the following condition is fulfilled. That means mixed directional fast discovery rate is restricted above by Q, and if this condition is satisfied, the following takes place. That means the sum of mixed directional fast discovery rate and fast acceptance rate is restricted from above. Also, then this restriction level, which restricts average fast decision when basic hypothesis is true. When this is chosen in such a way, the following inequality takes place. That means false acceptance rate is restricted also from above. For the case of directional hypothesis, type 1 error rate can be determined as follows. And taking into account definitions of the criteria which we introduced above, it is not difficult to be convinced in the rightness of the following inequalities. That means mixed directional fast discovery rate is greater than or equal to type 1 error rate, and we can introduce similarly the type 2 error rate by the following ratio. Comparing these criteria amongst themselves, we convinced that false acceptance rate is equal to type 2 error rate in our concrete case, and when this condition is fulfilled, the following inequality takes place. Also, the following theorem was proven that which proves that CBM7 with restriction levels given above and satisfied a condition, the Q is some probability, ensure a decision rule with type 1 error rate less or equal to Q, it is with the following condition. Because of the specific nature of the acceptance regions of CBM, it can so happen that making a single decision on the basis of existing information becomes impossible. It is when the test statistic belong to the intersection areas of the acceptance regions or does not belong to any of these regions. In such a situation, it becomes impossible to make a simple decision with a specified confidence level on the basis of the existing information, and more information is required to achieve this. If acquiring more information is impossible, then the restriction levels in the restriction conditions must be changed until a simple decision can be made. Then acquiring more information is possible. We appear to the sequential experiment just to increase a sample size and apply a procedure A which has the following form. The existing statistics for testing a subset of individual hypotheses is yi bar, which depends on two initial sums. Let us denote the test statistics on the basis of n observations by yin bar, and the sequential procedure has the following form. If test statistics belong to this region except left-sided alternative hypothesis, if these test statistics belong to this region except basic hypothesis, and if it belongs to this region except right-sided alternatives. Otherwise, continue sampling, collect next observations, and compute next statistics yin plus 1 bar, and so on until the test statistics belong to only one hypothesis acceptance region. For testing multi-directional hypotheses, the concept of total mixed directional fast discovery rate was introduced in these works, and it has the following form. For guaranteeing the level Q in testing directional hypothesis, we have to consider k minus 1 subset of directional hypotheses, where k is the number of populations, the total number of populations then the procedure of the result, we have the following inequalities. Where they are the total type 1 and type 2 error rates. The values of Qi in all these cases can be chosen to be equal, if Qi is equal to Q divided by K minus 1, or different, it is inversely proportional to the informational distance between the tested hypothesis is a subset of the directional hypothesis I, that is sigma I square, are known. For realization above developed method, the concretization on distribution laws of the statistics yi bar at hypothesis is necessary. It is necessary to determine the following conditional distribution densities. As was mentioned above, statistics yi bar is normally distributed. Therefore, taking into account the intervals of definition of the mathematical expectations at different hypotheses, we can suppose that distribution density of the statistics at condition that the basic hypothesis is true is normal with given parameters. Are completed by Monte Carlo method. Let us suppose that the variances of observation results are not known. In this case, we can consider two methods based on the maximum likelihood ratio and Stein's method. The essence of these methods consists in the following. The maximum likelihood ratio approach the density with unknown parameters values the second half of the sample at applying and it is used to make decision. This statistics is used to make a decision concerning validity of hypothesis. At applying Stein's method for averaging of influence of variances, it is necessary to use a priori distribution of estimator of the variance, which is difficult to be determined functionally with the known parameters at the considered case. Therefore, we act as follows. Construct confidence intervals of these estimators with the given confidence probability and assume that these estimators takes values from these intervals according to a uniform distribution. To find confidence intervals for these estimators is not difficult and has the following form. The squares and chi-square distributions with the appropriate degrees of freedoms and the quantile levels to overcome the uncertainty in the densities introduced above in Stein's method, which is caused by not knowing the values of the variances. We are averaging the effect of the variance on these densities by integrating them over the confidence interval of the variance with uniform density. In this case, conditional distribution densities take the following form. Let us introduce the following denotations. Then hypotheses with such denotations, hypothesis acceptance regions are the following. To be able to compare the offered method with the known one, we present computation outcomes of the examples considered in one of the latest work of the author Ishiba, published in 2016. In tables below are presented the results that are obtained by the methods of offered above and higher parametric bootstrap method, which was computed, used and computed by Ishiba in his work. Computation results are the, let's now consider computation results for computed different variances, probabilities of a priori probabilities of hypotheses are taken equal to each other and equal to 1 over 3. We consider it only 4 subsets, similarly of the Ishiba work. Therefore, k minus 1 is equal to 3, and therefore restriction levels in restriction conditions is equal to, in our computations, is equal to 0.0027. For the solution of restriction conditions, the necessary probability integrals were computed by the Monte Carlo method with the sum size is equal to 5,000. Obtained values of the Lagrange multipliers are the following. The values of total type 1, type 2, and total misdirection fast discovery rate are computed by Monte Carlo simulation of random sequence with 5 signed observations. The codes for all necessary computations were written in MATLAB. When using CBM principle complexity does not arise when the problem dimension increase. The computation time requires for making a decision in CBM is equal to the time required for classical Bayes method. The time required to determine the Lagrange multipliers certainly increase, but it is realized at the preparatory stage and does not directly affect the decision-making time. Let's, in the beginning, show the computation results was the case when variances are known. Computation results, the appropriate computation results are given in table 1 when a null hypothesis are true and table true when alternative hypotheses are true for different n sample sizes and different variances. And from here it is seen that CBM gives significantly better results than Hayes method by the criteria which we considered above. And the same situation we have when alternative hypotheses are true. CBM gives very good results, not only in comparison Hayes, but in principle these results are very, very good. From here, it is seen that for all computed combinations, type 1 error rate, total type 1 error rate, and total mixed ratio fast discovery rate, are equal to each other, and they all are significantly less than type 1 error rate of Hayes method. The power for all computed combinations are equal to 1 and significantly surpass the appropriate values of the Hayes method. The effort method perfectly distinguish one and two-sided alternatives, whichever is a possibility is not discussed in the work of Ishiba. Now let's consider, let's show the results of computation when variances are not known. Computation results obtained by the methods used maximum likelihood estimation of the unknown variances are given in table 3 when null hypotheses are true In table 4, when alternative hypotheses are true, the computations give us the same results as we had in the case of the known variances. That is, the reliability of made decisions in CBM are significantly higher than the results obtained by the Hyatt method. However, the number of observations required to make a decision is greater in CBM for this case than for the case when variances are known. And the table when alternative hypotheses are true. Now let's show the computation results obtained by Stein's method. Computation results obtained by this method when the uniform distribution are used as a priori distribution of the unknown variances are given in table 5 when null hypotheses are true, and table 6 when alternative hypotheses are true. Obtained results are very reliable. Probabilities of incorrect decision are equal to 0, which are provided by the big number of observations necessary for making decisions when alternative hypotheses are true. The number is especially great when alternative hypotheses are true. Let's make a short discussion. It is worth noting that the CBM method using the maximum likelihood method requires more observations than the same CBM method using Stein's approach to test the null hypothesis, while the situation is the reverse when testing alternative hypotheses. The computation results obtained by CBM and the Hyatt parametric bootstrap method are given in tables. In order to be able to compare the results obtained by these methods, Q in CBM is taken equal to 0.05, and type 2 error rate in the Hyatt method was taken equal to 0.052. From the results of this table, the superiority of CBM over Hyatt method is evidence. Moreover, unlike the Hyatt method, CBM allows us to distinguish between mathematical expectations differ from each other and mathematical expectations differ from each other and are ordered. The offered method of solving a novel problem for known and unknown variances of observation results with restricted type 1 and type 2 error rates based on CBM gives very reliable results that surpass the existing methods for today. It is a sequential method that requires a set of observations to make a decision, the number of which is especially large in Stein's method in the case of trust alternative hypothesis. Nevertheless, due to the large practical application of the CA-NOVA problem and the fact that in many cases the number of data is quite large, and the requirement for the accuracy of the decisions are higher, we consider the obtained results to be important and to deserve high attention. On the other hand, the question arises, what to do when it is impossible to increase the given number of observations, but a decision needs to be made with a certain level of reliability. We manage to solve this problem at the appropriate level for making a decision by considering not the arithmetic means of the normally distributed observation results, but their normalized values distributed by the student's law. The corresponding article is completed and will be published soon. Here is a short conclusion which repeats the same things which we told above. And on these slides and next slides are given references which we use at working on this paper. And thank you very much for your attention. Hello? Hello?
Hi, Carlos.
Oh, okay, I
Okay.
finished.
Yeah.
I
So,
finished.
so thanks for a wonderful talk. Now the floor is open for questions and comments. Anybody with any question? Any comment?
Well, I'm sorry, I forgot to switch my video. I'm sorry. I only just now saw this one.
Yeah, your screen is sort of off now. I don't know. Let's see. Should I try to make it full screen? No, it's still not showing.
What?
Nothing is coming up in the. I cannot see. Satish, are you there? Yeah, now it has come. Okay, fine.
Yeah,
All right.
I'm
So, yeah.
here.
So, anyone with any question, please? If anybody has any question, you are welcome to ask. We still have about 5 minutes time. Thanks for keeping the time. Okay. So, Carlos, looks like there is no more question or no question. You have probably precluded all the questions, or your presentation has been self-explanatory or too difficult. Maybe people have to understand and think about it anyway. But anyway, I enjoyed the presentation. I'm sure the participants also must have enjoyed it. The thorough,
Sir, good
very nice
afternoon.
presentation.
Sir, good afternoon, sir.
Very
Good
lucidly
afternoon.
presented. Okay. I
afternoon,
just
sir.
have a comment. I have to make a comment. Being the chair, I need to make a comment. So, since I am a co-author of this paper, I'm not going to make any critical comment about this paper, but I'm going to just make the audience, whoever is present, to be aware of what kind of generalizations we can have. And for example, this case, we have treated the situation of ANOVA with independent populations. So as you know, there are Box early in the 1940s have considered deviations from the basic assumptions of ANOVA. One of the basic assumptions is this independence. The other is the homoscedasticity. If you have carefully looked into the presentation in the slides,
Good afternoon, everyone.
you must have
Welcome to
noticed
Technical Session
that Cartlaws have
15A, an invited
considered,
session of
in
WSTA
a way,
2026,
the situation
11th
of
International Webinar on
heteroscedasticity
Recent Trends
when
in
we talked
Statistical
about the
Theory and its
variance of
Application.
xi being sigma
It
I
is my
square.
pleasure to introduce our session chair, Professor
That means they
Raghavendra
are going to
Sharma
differ
from
rather
Chaitanya
than
Deemed to be
talking about
University,
all of them
Hyderabad.
equal to sigma square. This is a sort of implicit construction, but that is one obstacle or other one generalization. The other one is the one where we need to think about dependency. So what happens? We have the ANOVA in case of dependent normal populations. For general dependency, that becomes a tough problem. I don't know whether Somesh is here. I had suggested this problem to Somesh Kumar. But Somesh Kumar and his students, they have come out to the solution. They discussed with me also. And the paper has come out or is about to come out. Okay, Somesh maybe will tell you, but it is about to come out, and I believe in a European journal, in statistics, maybe in the German journal. It's a nice paper where they talked about this deviation of from the assumption of the populations being independent. Maybe our results, maybe Cartlaws can think about it, generalized to the situation of dependency. General dependency again will be difficult, but a structural dependency, like a equicorrelated one, or some sort of a circular type matrix for the covariance matrix, that type of assumption. So this would be, I think, a generalization that could be helpful. Cartlaws, any thoughts, any comments?
Okay, thank you. Of course, it is very interesting, and we can try to continue. I developed this approach, as I told, to obtain such decision rule which restrict both type of errors and requires a very small number of observations. And this one improvement of this paper is already done. But what you said, it is very interesting, and let's continue our work, and let's try to solve this together.
Very good. Okay. Welcome suggestion, and I'll be happy. I think some of our participants also will in some time try to look at these and get some ideas. Okay. Thank you very, very much for an excellent presentation, and thank you for delivering this S.N. Roy Memorial Session lecture. We are very glad to have you over here. Thanks again. Over to you, Satish.
Everyone, on behalf of the organizing.
Thank you, Professor. Thank you so much. Very good, very excellent session. In fact, Fatima, please conclude this session, please. Thank you so much, Professor Ashish, for chairing the finding valuable time and chairing the session. And thank you so much.
It has been our pleasure, and we like to thank all the participants who are here in this session. Thanks from both Carlos and myself for getting into and being present in this session.
Yeah, I also wish to extend our gratitude to Professor Carlos.
Right. Thank you then.
Thank you.
Bye. The session is concluded.
Yeah.
Bye.
On behalf of the organizing committee of WSTA 2026, I extend my sincere gratitude to our session chair, Professor Ashish Sen Gupta, for his valuable guidance and for chairing this 15th technical session so effectively. I express my heartfelt thankful to our distinguished speaker, Professor Carlos J. Kachiashvili, for sharing their profound collaborative research and insight with us today in honor of Professor S.N. Roy. I also extend my sincere appreciation to all participants for your enthusiastic presence, active participation, and engaging interaction, which greatly contributed to the success of this special session. Once again, thank you all for being a part of this wonderful session. Thank you.
Thank you.
Thank you.
And now let us move to the next session. Pallavi, please.
Yes, sir.
Yeah.
Good afternoon, everyone. Welcome to the technical session number 16, a special invited session of WSTA 2026, 11th International Webinar on Recent Trends in Statistical Theory and its Application. This session is chaired by Professor Rahul Gupta from Department of Statistics, University of Jammu. Professor Gupta is a distinguished statistician, educator, and academic administrator with over 3 decades of experience in higher education. His research contributions span survey sampling, Bayesian statistics, reliability analysis, machine learning applications, and statistical inference. We are honored to have Professor Rahul Gupta chair this special invited session. We are delighted to have 2 eminent speakers with us today. Our first speaker is Mr. K. Narayananuni, former Director of Civil Registration Division, Government of India, a distinguished officer of the Indian Statistical Service. He has made significant contributions to India's civil registration system and census administration. He has served as an international technical advisor to organizations such as UNICEF and UNFPA. Today, he will deliver a talk titled Census versus Sample Survey. Is the debate settled only for statisticians? Our second speaker is Professor Dilip Kumar Ghosh from St. Thomas College affiliated to Saurashtra University. Professor Ghosh is a renowned statistician with more than 5 decades of teaching and research experience. A pioneer in the field of design of experiments, he has made outstanding contributions to statistical research and education. He will present his talk on balanced ternary designs. I warmly welcome all participants and now invite Professor Rahul Gupta to kindly take over the proceedings. Over to you, sir.
Thank you, Palvi. And thank you, Professor Satish Kumarji, for giving me another opportunity to be here in the conference as chairperson. So thank you very much. And this technical session is number 16, which I have been told to chair. And we have two eminent speakers, as Ms. Palvi just informed. One is a renowned Mr. K. Narayanan Unni. He's a Palvi has already told. He has retired as a technical advisor. He worked as among other things, he worked as a technical advisor to UNFPA Ethiopia. He has also worked as Deputy Director General, Ministry of Statistics or NSSO. He was also Deputy Registrar General in the Office of Registrar General. So many prize positions, many great positions he has held. And apart from that, he has done a lot of work in statistics. He has many publications to his credit on the census and the complete enumeration issue registration systems in India. So he has ample of knowledge, and with that I welcome Shri Unni Krishnan K. Narayanan ji to take up the forum, and please disseminate your scholarship to the audience. Welcome Shri K. Narayan Unni ji. Please take the dais and make us aware.
Thank you for the welcome. I hope I am audible to you all.
Yes, sir. Very nicely. You are audible.
Yeah. Now I am extremely happy to be here presenting something which is different from all the technical things which you are having all this through this conference, because now it's probably a little something like a joke among the total technical discussions you are having. Now, the topic which I am going to discuss about is basically, it's titled Census versus Sample, whether it is argument which is settled only for statisticians. Why I am talking in this manner is basically because during my tenure in the government of India, several times I had been hearing about questions about whether the sample size is sufficient, the sample is enough for census, it should be expanded like that. So that is the basis for this talk. Now, actually, I had prepared a presentation. Unfortunately, an hour back, I noticed that I am not able to open that file. So I'll be actually giving a talk only. I will not be able to present anything right now. I'm very sorry for that. Now, when we talk about the official statistics in India, we cannot forget about Mahalanobis, whose birth anniversary we celebrated a few days back at the National Statistics Day. Mahalanobis was the chairman of the UN Statistical Commission for 2 sessions in 1950s. And that was the period when we actually started experimenting with use of sampling in the official statistics, because the NSSO's estimates used to be part of the Government of India statistics requirements. Now, the contribution of Mahalanobis is not well known, but the contribution of Mahalanobis in developing the official statistics system is probably that much well known to the people. In fact, I remember reading sometime back that in the run-up to the 1951 census, and there was some discussions about use of sampling as much as possible, and somebody had written some time back an article where he says that Mahalanobis suggested that we can have more of the data collected through sampling. That was in 1948, 49, that period. Now, we can't think of that today, that somebody would have said like that at that time. Now, the census, somehow at that time, Government of India did not go that much with the suggestions of Mahalanobis. It actually tried to expand the census. And the 1951 census and onwards, the number of questions that are being canvassed in census was going on increasing. It may be recalled that the census in India started at a time when there was no statistics available for almost anything in the country, except for some data on commercial statistics and things like that. So that is a time when we started the census in 1951. 1881. So it is important to see that with that background, some of the questions which are being collected in census, like the question on caste, etc., that was inevitable. But later on, we found that 1951 onwards, there was a drastic expansion of the number of questions which was being canvassed in census. There are the questions on economic activity, then questions on the housing conditions. Then later on, we had questions on employment, unemployment, and things like it was going on increasing. Now, in the 2027 census, we had the quality of housing, where you have a certain type of assets in the house, like radio, television, car, things like that. What are the facilities available to the households, where there is electricity, water supply, what type of sewage available, etc. This type of number of questions are there. And then on top of it, we are going to have the questions for individuals, which is to be notified, which will be in the second phase of the census. Now, I have participated in the data usage conferences for the census from 1991 onwards, 91, 2001, 2011, and the census which didn't take place 2021. I was also a member of the technical advisory committee for the census in 2011 and 2021, and had also participated in the similar the meetings of the committee in 1991. Every time I have noticed that people come with a lot of demands for, you collect this also, you collect that also. And sometimes what happens is the data which many people demand are collected, but then you find that it is not useful. The data is either quality is very bad, or there is a lot of under enumeration, or the data that has been collected is not what people wanted. Just to give some examples, the 1981 census, it was decided that you will collect the question on unemployment. That is basically whether are you seeking or available for work. The initial plan was this data will be released at village level. But when the data were tabulated, it was found that it is not that reliable at village level. Probably it is reasonably acceptable at district and higher level. So finally, the village level tabulation plan was completely dropped. In 1991, the Ministry of Defense said that we don't have the number of people who are ex-servicemen, because there are a lot of people retired from the British Army and all that, who are not necessarily getting pension. So we want to collect the number of ex-servicemen and the number of pensioners. So a question was asked in the census, whether you are an ex-serviceman or whether you are a pensioner. And are you getting if you are a serviceman, whether you are getting a pension from the government for the military service. Unfortunately, again, the data, when it came, it was found that it was absolutely useless data. In fact, the census organization itself all the officers were against adding this question because only a very small proportion of the population could be in that category. This is some data which actually should have come from the administrative statistics. In 2001 census, again, there was questions on land owned by the household, cultivable land owned by the household. Now, again, this was found to be a useless set of information, because many people actually didn't ask the question properly, or sometimes the units they used are not necessarily the units which are being asked for, because data were the figures were to be recorded in hectares, and people made mistakes in that. All the things, and data could not be tabulated and published. Now, when we look at the use of sampling was used in census very extensively. This is something probably news to many of the participants here. In 1941 census, because of the Second World War, the tabulations were not done properly, and the data were tabulated only on the basis of a sample tables. And in 2001, tabulation of detailed industry and occupation data were done only on the basis of a sample, but other data were 100%. So technically, sampling was used in a census for quite a long time. Now, one of the important questions that comes when you look at the census questionnaires and the details of the questions is, do we need to collect all this information in census, or can we make use of sample surveys on that? Now, that actually, and to answer the question, before we answering the question, we should actually have some idea on what are the information that we require on a census basis. Because the idea of having official statistics doesn't mean that all statistics are required at all geographic levels. Because planning and policy making does not take place at all levels of the all geographic levels or all administrative levels in the country. So some of the plans and policies are made at central level, some are done at state level. So depending on how the plans and policies are made and for what purposes they are made, according to that only should be the data collection also designed to. Now, when you look at census, the biggest advantage of census is its ability to provide data at village level. Then, when you say that, that is the level at which the data should also be accurate. Every level at which we present some data, that should be accurate at that level, at least. So now we look at some of the data which are required at village level. One is the data for delimitation of electoral constituencies are recorded at village level for with the smallest possible level. In fact, village level and urban ward level, because you need to redraw the constituencies every time. It is not necessarily only for parliaments and state assembly constituencies. Even for village panchayat level, panchayat wards carving out, you need the data. So that is one where you need data at a very low level, and also for the reservation of the concerned constituencies. Now, there are some other data which may be useful at village level. For example, data like percentage of children not attending school is useful in education planning if somebody wants to plan things properly. And there may be there are some other indicators. I am not going into the details of this because that is not the purpose of my this discussion itself. Now, in some cases, when I look at it, some cases there may be data that is useful in identifying districts with certain characteristics that can be further studied. I'm like you may be able to identify districts with which are backward in certain type of items, but you need to know the villages or the individuals who are households which are having that those characteristics. You need to have much more detailed surveys. So their census cannot help in pinpointing everything in detail, because you are sending the census enumerators with just 1 or 2 days of training, and you can't expect them to go into a lot of probing questions and get details. And in today's scenario, we are having what is called self-enumeration, where the questions have to be kept simple, and you can't expect the people who are filling up the self-enumeration questionnaire to go through all the details of definitions and the concepts involved in the just to give an example, the question on economic activity itself was around 3 or 4 pages in the last census. The question on where somebody is what you call physically challenged, those questions, the explanations were running into several pages. So you can't expect somebody who is filling up the questionnaire, especially when the person is doing it on himself, to read all these explanations and fill up the questionnaire. So you need to keep all this in mind. Now, so why the census, or why are people asking for all sorts of details in census, and why it is being collected? In my own feeling is, one is there is a lack of awareness of advantages of sampling still persisting in the country, especially among the administrators, the policy makers, and all the such levels of people who are at a very higher level. Then another issue which I have noticed is the lack of awareness of sample size requirements. Many people think that a small percentage of population is an inadequate sample size. We all know that the sample size is to be determined in terms of the numbers and not on the percentage of population as such. But it's not as a percentage of units. But the many people think that it is not that way. And just I am remembering a comment made by the CEO of Nidhi Aayog around 4 or 5 years back when discussing about the unemployment data. He was mentioning this. He said the sample size used by NSSO is a very, very small percentage of the total population. Now, that is something which the statement which was made because of his inadequate understanding of what is how the sample sizes are decided in a sample survey. Then another problem in government is you determine the sample size based on a particular parameter. But when the survey is all being decided, then several other parameters are being asked for the data collection. Just a simple example is SRS, the sample registration system, which estimates birth rate, death rate, IMR, etc. The sample size is determined basically based on IMR, the levels of IMR in the infant mortality rates. How much sample is required to estimate infant mortality, because other things like birth rate and death rate are much higher percentages, so it can be